Starting with the name of Allah, who is the most merciful and the beneficent. Today, I'm going to present my final year project, Automatic Centralized Timing and Bill System for Sukkur IBA University. Me, Lukman Khan, with my groupmate Mudassir Raza, working under the supervision of Sir Dr. Abdul Basir. These are the content of our presentation. The introduction, problem statement, then the main aim and objective. Then we will discuss about the methodology for project, the software simulation of the circuit, the results discussion, conclusion, future recommendation, and the references. Introduction. As we know, in the market, there are a lot of automatic and manual bill system, but those systems are only suitable for schools and colleges because of same timetable for the classes. Now we are designing our system for university. So based on our university timetable, weekly timetable of each class and lab, we present an idea to design a prototype to connect multiple bills in each room along with a display showing the synchronized time and date in each respective class and working according to their respective class timetable. For example, the bill in 407 and in 408 or 409 will rank per their respective timetable. Problem statement. The main issue with the implemented bill system is it cannot fulfill the need of our university because we have no fixed timetable. We have different discipline and semester students attending different classes in the same block. The manual system need a person for ringing the bell, and we provide proper salary to that person. And the in charge might forgot to ring the bell, means there is chances of inaccuracy regarding time. Moreover, the clocks in each classroom do not show the same time as in the other classroom, means the clocks are not synchronized. There's always some delay or desynchronization among the clocks of the classroom, which will create disturbance in time-sensitive events like exams, quizzes, which are conducted in different rooms. Aims and objective. We have four main aims and objective of our design system. Designing of automatic bill system, then synchronization of clocks, then implementation of emergency system, and then the energy management system of Sukkur IBA University, and to reduce human effort from manual switching operation at lowest possible cost. Methodology. The design model consists of many input and output peripherals such as RTC clock DS1307 module. There is push buttons, microcontroller, buzzer for ringing the alarm, LCDs displays for displaying time and date, along with to show proper message of the given interval. Now for clock synchronization, we use RTC module as a main source to feed same time to each clock, which automatically count every second once enabled. We program our device in C language, in Arduino language, to ring the bell according to the required timetable. We use DC voltage to enable the relay circuit, which turn on and off the bell to ring. Now, here Arduino and RTC communicate serially, means send data bit one after another over a single channel with the RTC DS1307 module. The IC has features an inbuilt power supply sense circuit that can detect power failure and switch to the backup supply. Yeah, this is the advantage of this IC. We have used display for displaying the real time in class. Lastly, we analyze the result and collect data from the final output. Flowchart. First of all, we need to initialize RTC. RTC feed time to the microcontroller. Then the read time will be displayed on the LCD of room number one and room number two. Basically, our design up to now, we design our system for two rooms. So display time room number one and display time room number two for the separate rooms. Now for room number one, here is the condition will be checked. If the time is equal to timetable, set timetable, then the bell will ring. If this time and this condition false, then the loop will again mm, run. And in this way, this is the overall flow of our project. Block diagram. The working of our project will clarify this block diagram. Now, here we are considering three rooms. Room number one, room number two, room number three is a master unit of our project, a central device consists of microcontroller, RTC module, and a battery bank, which is connected to each room through DC wires. We are going to set separate displays, and we can see that the time is synchronized second by second here. Master unit. It consists of microcontroller. We already discussed RTC module, DC battery bank, relays, and push buttons. RTC module provide real time and date, which is connected to the microcontroller. Battery will provide backup supply, and single pole double through SPDT relay work as a switch, as a decision making for the to ring the bell. Each bell will ring according to the timetable of the specific class, and the LCD of each room will provide exact time and date synchronously. Pure simulation. First of all, we simply define the software parameter which we use in our project. The software we use for simulation is Proteus, Tinkercad, Arduino, Eagle, and SolidWorks. Now, Proteus and Tinkercad we use for circuit simulation, Arduino IDE to run the coding, Eagle to design PCB, and SolidWorks to design 3D model.
This is the simulation result, the whole circuit, simulation circuit. Here is Arduino, real-time clock. Real-time clock feeds real-time to Arduino that is displayed on LCD display. And here is bell, buzzer, and relay. Arduino makes decision when the time becomes equal to the timetable that we have set in Arduino for bell time, then the circuit will be closed and the path will be complete to ring the buzzer. The display, time display, and these are some push buttons which are used for emergency case. When we have emergency, we can manually press the emergency button to ring the bell and display the message of emergency in respective classes to show that there is an emergency. So these are real-time results that we have achieved on our prototype. These currently we work for two rooms to synchronize the clocks of two rooms. This is the display. This figure shows that both the rooms clocks or both the displays are synchronized second by second. There is no clock drift. So in our system, we have also emergency system that in case of emergency, the control room can push the emergency button and the emergency message will be displayed on all the LCDs corresponding rooms or respective rooms where we want to show our message. The message of emergency will be shown in these rooms, and bell will also ring. So if there are holidays and we don't want to ring the bell, we can disable the bell for this time, for these days. If there are holidays like Sunday, we can disable the bell also. And the message of bell is disabled will be shown. Okay. If there is any error in our circuit, like circuit is open, the display will show that there is error and check circuitry message will be shown on each display. So this is the 3D model that we have designed on SolidWorks. This is the whole circuitry, Arduino, time display and buzzers, two buzzers for two rooms. Right now we are considering our project for two rooms. So we uh, implemented the prototype of two rooms, and this is the whole circuit that we have. Here is the buzzer that the figure a little bit not clear. Here is the buzzer for first room and time display for first room and time display for second room, buzzer for second room. Uh, so uh, our target was to design a prototype of an automatic bell system, synchronization of clocks, and implementation of the emergency system in Sukkur IBA University within a separate rooms. We achieved this target while using microcontroller, real-time clock DS1307 module, display and logic programming. In case of emergency, we had manual button in our device and also having an option of to disable the system. It was our project. It can be further extended to make for a whole block or uh, more than two rooms. It can be implemented for real time by a few amendments. It can further be extended while using uh, to for energy utilization with the automation of classrooms, air conditions, and lights. More often, students after leaving class they leave the lights on and air conditions. Say for example, if class ends at 1 p.m., so it must be automated in such a way that at 1:10 the lights and air conditions must be off so that we optimize energy utilization. And the same system can also be implemented for industry time shifts. We can make the system as a flexible while using Internet of Things IoT system, Wi-Fi module through Wi-Fi connection, and also making an Android app to make it flexible for changing of timetable setting. So it can be further extended to exam system, and these are the references where we get help and we studied these articles to make our own system we help from all these search papers. The overview of our project. Centralized timing and bell system for Sukkur IBA University. Our aim was to design an automatic bell and clock synchronization of the classrooms to an implementation of an emergency system in Sukkur IBA University to reduce the human effort and manual switching operation at minimal effort. So this is the flow chart of our first we have to initialize real-time clock. The real-time clock will feed real-time to microcontroller. This real-time will be displayed on the both rooms displays, time displays, LCDs. Uh, right now our project is for two rooms, and then the condition will be checked. Condition for the timetable that we have set for the bell time of the room 1. Let's suppose we set the timetable for room 1 to ring the bell. If the condition is fulfilled, if the time is fulfilled, that time becomes equal to the set time that we have for the bell time. The bell of the room number 1 ring and will stop. If the time not equal to the set timetable, then then it will be again read time and again the condition will see. So the loop will be continued. In the same way for the second room. So this is the overall flow chart. These are the few real-time results that we get from our project. This is the clock synchronization that is clearly shown. In case of emergency, we set manual buttons like emergency button, bell disable button, and stop button. So in case of emergency, we can manually ring the bell and the emergency will be shown on both of the displays. In the same way, bell can be disabled for holidays, and if there is any circuit error, like circuit is open, the message will be shown on LCD displays that the circuit is open. So we issue this target while using microcontroller real-time clock DS1307 for two rooms. It can further be extended to implement it for a whole academic block or more than two rooms. So this was the overall overview of our project. Thank you.